Source transformation. Source transformation is another method for simplifying the circuit. It is a process of replacing a voltage source Vs in series with a resistor R by a current source in parallel with a resistor R or vice versa. In this method, we need to remain the reference terminals. This method can only be applied to a linear circuit. So this is the example how we apply the source transformation technique. Okay, we can convert the voltage source over here with the current source over here. So how we convert the voltage source into a current source? So you need to apply the same value of resistor. So it only can be applied to the circuit that voltage source in series with the resistor or the current source in parallel with the resistor. Source transformation can also be applied to a dependent sources. In order to convert the voltage source into a current source, okay, we use the Ohm's law, which is we can get the value of Vs by using Ohm's law, which is Vs will equal to ISR, or you can get the value of Is by using an Ohm law, which is Vs divided by R. Before we go further to the example, okay, source transformation does not affect the remaining part of the circuit. Source transformation is a powerful tool that allows circuit manipulation to ease circuit analysis. However, we should keep the following points in mind when dealing with the source transformation. The first one, the arrow of the current source must be directed to the positive terminal of the voltage source. One more thing, the value of R cannot be 0, and also the value of R cannot be infinity. Next, we go to the example. In this example, you need to use a source transformation to find V0 in the circuit of figure 4.2. This is your V0. This is the value that we are looking for. In this circuit, you have two independent sources, which is the first one is 3 ampere and then the second one is 12 volt. By using source transformation, we need to check first the current source must be in parallel with the resistor, and then the voltage source must be in series with the resistor. Is these two conditions met? So then we can apply the source transformation. So in this circuit, we can see that 3 ampere over here is connected in parallel with the 4 ohms, and then the voltage source over here connected in series with 3 ohms. So therefore, we can convert both source into another source. So that means we can convert current source into a voltage source, and then we can convert voltage source into a current source. So let's transform the current and voltage source. So if you see in this circuit, we convert the current source into a voltage source, and then the voltage source being converted to the current source. So in order to get the value of the voltage source, we are using Ohm's law, which is Vs equal to ISR. So in this case, Is is 3 ampere times with 4. So therefore you got 12 volts. 12 volts must be in series with 4 ohm resistor. So next, for the voltage source, we convert the voltage source into the current source. So the voltage source value is 12 volts. So in order to convert into a current source, we use an Ohm's law, which is Vs equal to, which is Is equal to Vs divided by R. So therefore Vs is 12 divided by 3, so is equal to 4 ampere. So 4 ampere current source must be in parallel with the resistor. This circuit shows that we already transformed the current source into a voltage source and a voltage source into a current source. So we go to the next steps. If you see here, we can simplify the circuit by combine resistor 4 ohm with 2 ohms. So therefore, the resistor value become 6 ohms over here, and then 6 ohms is in series with the voltage source 12 volts. So therefore again we can convert this voltage source into a current source. So at this part you can see we are converting the 12 volts voltage source into a current source. So in order to get the value of the current source, so Is equal to Vs divided by R, which is Vs is 12 divided by 6, so is equal to 2 ampere. So the new current source value is 2 ampere in parallel with the 6 ohm resistor. Next steps, we combine the 3 ohms and 6 ohm resistor in parallel. So if you see this circuit, now the circuit becomes all are in parallel circuit. So therefore, we can further simplify this circuit by combining 6 ohm resistor with the 3 ohm resistor. So bear in mind, you cannot combine 6 ohm with 8 ohm due to the value that we are looking for is actually at 8 ohm. So please don't change the 8 ohms configuration. So we combine 6 ohm and 3 ohms. So therefore, 3 ohms parallel with 6 ohms give you the value of 2 ohm over here, right? So now R become 2 ohms parallel with 8 ohm, and also at the same time, if you can see the current source over here and the current source over here also can be combined together. So when we combine 2 ampere and 4 ampere, so it's become 2 ampere. So by looking at these circuits, so this is the simplest circuit that we can get by using a source transformation. So therefore, you can find the value of V0 if we get the value of I. So the value of I can be found using current divider rules. By using a current divider rule to get I0 and V0, so therefore I naught is actually equal to 2 divided by 2 plus x times 2, which is 2 is the current source. So therefore, I naught value is 0.4 ampere. By knowing the value of I naught over here, so by using Ohm's law, we can find the value of V naught, which is V naught equal to x times I, which is x times 0.4 equal to 3.2 volts. Therefore, V naught equal to 3.2 volts. So if you see here, we can do a repetition of source transformations in order to get the simplest circuit. So when we get the simple circuit, we can apply a very basic rule to get the value that we are looking for.